that, I am very pleased to introduce our featured speaker of today, Justin Fear, who's Director of Cyber Intelligence for Darktrace. Justin, the show is yours.
Great. I just want to thank you guys for having me on board. And again, my name's Justin Fear. I work with a company called Darktrace. And we'll just go over a real quick brief background about our company as a whole. We were founded a couple years ago by mathematicians from the University of Cambridge and cyber operations experts out of the UK, many of which came from former intelligence community positions. And they wanted to take a different approach to security. Basically, it was agreed upon that the perimeter is no longer enough to keep an adversary out. And while we would never tell a company to realize in this day and age, if an adversary wants it, they will. I always like to say that if you build a wall, I'm going to show up with a taller ladder, and if you put barbed wire up at the top, I'm going to dig a hole underneath, and when all else fails, I'm just going to bribe somebody on the inside to do it for me. An adversary with the right patience and resources will breach your network. And so Darktrace is taking an inside-out approach to network detection. And we tell our clients it's not a matter of when you get breached, it's a matter of, it's not a matter of if you've been breached, it's a matter of when you get breached. And we're all about the earliest possible detection. And how we do that is by machine learning. And specifically, Darktrace is using a type of machine learning called unsupervised machine learning. To date, we've got over 2,000 deployments worldwide, and we're seeing massive, over 600% year-on-year end growth. The company has more than doubled in size in just the last 12 months. I think as of this morning, we are at 372 employees, and we have headquarters in San Francisco and Cambridge, UK. So why did we take a different to security? And I think the easiest way to answer that is just that the business landscape has changed drastically. I think we could all agree networks are far more complex than they've ever been. Many companies are outsourcing their IT and even IT supply chain. We heavily rely on SaaS application and cloud environments, virtualization, and I won't even discuss bring your own device and wearables. We all know the nightmare that those are. And then lastly, the Internet of Things explosion that has riddled the media over the last couple months with the various exploits and DDoS attacks coming out of those. And so because of that, we had to take a different approach to security. And if you look back at a couple different breaches just over the last couple of years, you can kind of see how the attack vector has changed. Yahoo was the first billion record breach. LinkedIn, over 117 records, specifically passwords. What doesn't get reported a lot on that is that a lot of those passwords, which were reused passwords for corporate accounts and other people's personal accounts, we have seen a large uptick in that. Most recently, the TeamViewer desktop sharing app, they reported that as a result of the LinkedIn breach, they saw a large uptick in unauthorized access as a result of that. And so because of that, we feel that companies need to be a little bit more vigilant and start adopting different approaches to security outside of what we've grown accustomed to. The last thing I want to point out that I don't think gets talked about a lot is not the Yahoo billion record breach. We all know how bad that was, but the other underlying effect of that was the effect that it had on their merger and acquisition with Verizon. During the time that breach was released, they were in discussions for a multi-billion-dollar merger and acquisition with Verizon. And when that got leaked, the value, that discussion price got decreased substantially. And then what we saw was another attack get released, and that value got decreased even more so. So I really think this is the first time we've seen an attack potentially aimed at swaying the economic market space, and not so much just politically driven or monetarily driven. So I really think that's an interesting aspect, and I hope I'm not right in that regard, but I think that could be foreshadowing what we should expect to see in the next 24 months. Another thing we see on the rise is ransomware. It's not just a matter of stealing data anymore. It gives attackers a fast payday. And it's increased. I think that metric's probably even a little underreported. It's increased probably threefold. And most of the companies that are affected by it end up paying the ransom, which I know in the community is a bit of a 50-50 split whether you should or should not do that. And what Darktrace is doing is we're detecting it as early as possible. So instead of 100% data loss, we're trying to minimize that down to 2 or 3%. Data manipulation and trust attacks is another attack that we're starting to see quite a bit. This is the type of attack similar to that Yahoo attack I was talking about that I really think doesn't get enough focus. These type of attacks are solely aimed at eroding the public's opinion of a company. So it's not a matter of stealing money. It's not a matter about website defacing. It's all about swaying public opinion. I think we saw that more than anything in this most recent election, specifically with the DNC hack, the World Anti-Doping Association hack. Actually, even as recent as this week, soccer star David Beckham's email was leaked and displayed all over the web. And he was held kind of at ransom for that. So I think we're going to start to see more and more of those attacks. And I think it's going to call into the question the validity of data. We're going to look at data and we're going to have to determine, is this valid what we're seeing? Has it been manipulated in any shape and form? And so I think those trust attacks are something to kind of keep your eyes peeled and look out for as we move forward in the security industry. Now, I mentioned Darktrace is taking a different approach, and I'll go into a little bit about how we do that. So I think it's agreed upon throughout the community that networks in this day and age, and I mentioned a couple slides ago, have gotten so complex to the point where it's not humanly feasible for me to solely rely on a log aggregator or a SIM and solely rely on my endpoint protection. So of course, defense in depth is always going to be the model I think a lot of us adopt. But even that, it just becomes such a chore of even knowing an entire network. And so what Darktrace does is it's what we call is self-learning technology. And it actually does just that. It learns the network. And we do this through what's called unsupervised machine learning. We deploy in the network. It takes about 1 hour to deploy, literally rack and stack the box and use either a network tap or a span port off of a router. And it automatically starts baselining and it gets a sense of self. We call this the enterprise immune system. And the reason we modeled our approach after the immune system is because networks are very much like the human immune system. Every network is different. Sure, the fundamentals and the architecture are the same, but every network is different. And just as every listener on this webinar has their own immune system specific to them, every network can be treated the same way. And when something gets introduced to my immune system, for example, I alert, my body reacts, temperature is raised or other physiological things happen. And a network is very much the same way. When anomalous activity is introduced to it, we should be able to identify that. But as I mentioned before, because networks have gotten so complex and attackers have gotten much smarter, this is very difficult to do in this day and age, and that's really where this unsupervised machine learning comes in. The best way I could explain unsupervised machine learning to someone that's never heard of it before is really just a more efficient way of looking at the data. And if you really want to look at your network as a big data set, that's what we're doing. Your network is probably the biggest data set out there, and it gets even more complex as it changes every second. It's growing, it's shrinking, things are getting added to it, things are getting subtracted to it. So how do I keep up with that? And a human simply can't crunch that many numbers at one time or pull out subtle patterns and anomalies. And this is where unsupervised machine learning comes in. It requires no customer configuration. We don't want any prior knowledge, and that's the unsupervised piece of it. You'll hear a lot in the media, this talk about machine learning, and there's really two camps. And I would stress, as you talk with other companies that are talking about machine learning, ask these questions. Are you using supervised versus unsupervised machine learning? And the biggest difference between those is supervised machine learning is training the system. I'm feeding it data, and I'm teaching it what this is. So if I'm training a system to learn to tell the difference between a dog and a cat, I'm going to show it a bunch of pictures of dogs and cats, and I'm going to train it to be able to do that. Unsupervised is exactly the opposite. It learns on its own, and it makes decisions based off of that. And that's really important, from our perspective, because malware is getting very sophisticated, and I don't think signatures and heuristics are enough to rely on these days. It takes a matter of minutes, in order to resignature, a piece of malware. So you would literally have to be updating your AV engines and your endpoints, every second to keep up with that data. And that's why that unsupervised piece, that not helping the system, really is key. The other thing I like to point out is, with that, we can support teams with varying levels of security and skills. I've worked with hundreds of customers at this point, and of course, the common theme is finding skilled security practitioners. And by taking the heavy lifting off of doing the analysis of all that network traffic, it allows a team that might be running a really lean operation to get better use of the resources that they have. And then lastly, we're able to deliver value almost immediately. We're learning and adapting as we move on. So the system gets deployed, and it's constantly adapting with the network. It's constantly learning, and it's constantly changing with the actual network. And so that's the fundamental approach of Darktrace and the unsupervised machine learning that we're using.
Hey, Justin. This is Will. I have a question for you that I'm commonly asked, or kind of comes up in conversations, and it's really around. You've done a great job of distinguishing between the different types of machine learning. Can you help us understand what the difference is between deep learning, machine learning, and artificial intelligence, or is there a difference?
Sure. Yeah, there absolutely is. And the first thing I would say, and I always like to clarify it, nobody to date is doing true artificial intelligence. True artificial intelligence would be a system that totally mimics a human person and can pass a Turing test and is actually thinking for itself. So I think a lot of marketing is kind of taking advantage of the term AI. What you have, though, is different camps, different subsets of artificial intelligence. And that's where machine learning, deep learning, neural networks come from. And so, if you really wanted to lay it out, you could say machine learning is really a way of teaching a system, that's kind of heading towards artificial intelligence. It's not true artificial intelligence, but it's a computer that is truly learning. And then you've got deep learning, which is taking features from the machine learning model, but it takes it one step further by constantly teaching itself new abilities and adjusting existing ones. And so it can look even deeper into a data set, and it can potentially even fill in gaps that might be missing from a data set. And so that's really the two big players you're going to see, specifically in regards to the cyber community. Now, the other thing I want to point out is there's different use cases for machine learning, and just because Darktrace uses unsupervised doesn't mean there isn't good use cases for supervised machine learning. If I was looking at signatures, because that was what my product did, I might use machine learning to look at hundreds of thousands of samples of malware in order to maybe predict what the next type of malware is going to be. So there's a time and a place for each of the different types of machine learning. Does that clarify things a little bit?
Yeah, absolutely. Thank you.
Sure, sure. So I want to go through a couple threat examples, real-world examples that we found on some of our customers. And I always I try to pick obscure items because it's my professional opinion that the industry as a whole is still very much hyper-focused on the desktop server model. And it's usually the really interesting cases where it doesn't have anything to do with one of those devices that really gets my attention. And I think we're going to start to see more of that as we rely more on these headless systems and these IoT systems and stuff like that. So we had a company in India, I believe. It was a manufacturing company that used biometric fingerprint scanners for time and attendance, as well as throughout the building. And I agree that, putting one of those that device should have never been on the internet. So it's unclear why that device was on the internet in the first place. But as a result, an attacker was able to exploit this device. Now remember, fingerprint scanner, it's a lightweight, headless Linux device, doesn't really have a keyboard and a screen to it. It's just up there on the wall with a little keypad. And so an attacker was able to gain access to it, and with a known vulnerability out on the web, gain control of it. And in addition to altering binaries on the actual system, the attacker did a great job of cleaning up after themselves. They deleted lines in the log files that pertained to them only, and then set the time back in the log to make it look like it hadn't been altered. Now that's important to note because a lot of other legacy systems rely on logs. Well, how can I rely on logs if logs can be manipulated? And I think that's a great example of why we can't rely on that type of security approach anymore. I wouldn't say get rid of it. I still think there's value in that data, but it's not enough to rely on it. And so in addition to breaching this scanner, which is already interesting in and of itself, the more interesting piece comes afterwards. The scanner itself, we actually had a trusted relationship with the server. Unlike what we see in the media in this day and age where everybody's removing data and exfiltrating out tons of data, we actually saw strong indicators that somebody introduced data to the database. Now, why would somebody do that? Why would you introduce fingerprints or different time check-ins? I could say, just based off of all the different spy movies I've watched, it could be to maybe place somebody someplace in the building that they didn't belong, or even give somebody that already is on the inside, an insider, access to a part of the building. And so, again, you have a couple different anomalies here that were very interesting. The last thing I like to highlight about this particular case is because it was one of those headless, lightweight devices, they don't run antivirus clients on a lot of these devices. And so a lot of times breaches like this happen and they go unknown. And it's only a matter of time, sometimes upwards of months, if not years, before it actually gets detected. In this particular case, we were able to detect it very early on. I can always tell how serious a breach is with our clients because usually I don't get to get the final story about it because their general counsel will usually not let them discuss it, or it might go to legal proceedings. And in this particular case, I'm not exactly sure where it went from there. But nonetheless, it was one of the more interesting finds that we've come across, as a company. Insider threat is something I like to focus on quite a bit, actually. With my customers, I spend a lot of time looking at this for a couple reasons, because it's probably one of the hardest things to find on a network. You can't write a rule or a signature. You can't always predict when an employee is going to go rogue. And in some cases, the employee has guilty knowledge of how the network's designed and is very easily able to evade detection and bypass various protocols that were put in place for other employees. So insider threat is something that's very difficult to find. So in this particular case, we saw a software engineer, and again, that's already an interesting point. Software engineer, to me, means privileged access, somebody that's got probably some root level credentials on some servers. And what we saw was, the computer acting anomalous to itself. Now, I mentioned before, very high level how Darktrace, uses unsupervised machine learning. the reason we were able to detect this is because we don't ever look at any one system or user black or white. We look at it from many different dimensions. So in this particular case, this device was acting anomalously for itself. It was acting anomalously for the entire network. Darktrace does something called clustering, where it finds like devices on the network, and so this device was acting anomalously compared to other devices that look similar to itself. And so we're able to identify a number of different anomalous actions. And what it turns out was the employee was sending large volumes of source code, which, you know, for this gaming company is their most valuable intellectual property, to his personal email account in order to complete his work over the weekend. Now, I know a lot of employees don't think of that as malicious, and again, this employee didn't have malicious intent, but I always like to tell companies, you know, that are allowing employees to do that, that if you're allowing your data out, then you better be sure that the system that data is ending up on, whether it's their residence or someplace else, is up to the same security standards as your company. And if you can't be sure of that, then I would think twice about allowing it even at the policy level. And again, their traditional security tool would not have caught this. I'll give you another example, not on the slide. We had a client that, again, had a network engineer with root level access to a lot of very serious infrastructure. And same thing, they were connecting back home to their computer. What was interesting is, though, the home computer actually was wide open to the internet, meaning anybody could actually see what was on that FTP server in the computer. And on there was a folder with the company's name. And if you looked in that folder, you could actually see that the employee had VB script files that were meant for Bitcoin mining and Bitcoin pools. Again, it's unclear how the employee was planning on using that, but you could come to the assumption that somebody with access to data centers and large servers might have been planning to potentially do some Bitcoin mining with those resources. And so I classify both, you know, the first one is a non-malicious insider, the person that's just kind of not really thinking about the security ramifications, versus the malicious insider, the person that's got clear motive and objective and thought behind what they're attempting to carry out. And it's probably one of the hardest things to catch. And I was shocked when I left my job as a government contractor to see that this is happening on a daily basis. I am actually reporting this on probably 80% of my clients, in some cases weekly, over and over again. And with that in mind, the other thing I like to always point out is thinking a little differently about security. You know, get your HR teams involved with security. It's not just the security team. It's the HR team, it's the networking team, it's the physical security team, you know, and I think, you know, collaboration amongst all those other teams is really a great way to combat the insider threat problem, which I think is something that's probably going to get much worse as we move forward. Ransomware, of course, we all know ransomware. It's been beaten to death in the media. We're catching it all the time. You know, in this particular case, a receptionist opened, you know, a legitimate seeming email containing an invoice. Now, this is a recent, you know, in the last couple of months, ransomware model where the spear phishing, you know, of the emails has been really, really sophisticated in that even well-trained employees that know not to click on the links are being duped into it. You know, they're using file names in the attachments that are file names found on the user's computer. You know, it's really, you know, a problem that's evolved immensely over the last 12 to 24 months, and I think it's just going to continue to. You know, and so as a result, Darktrace was able to detect this very early on, and instead of 100% of, you know, their data getting encrypted and lost, we were able to minimize that by 2 or 3%. And so ransomware, I think, is something that's going to be around for a little while, unfortunately. The other thing I'd like to point out is that, you know, ransomware is now a service out on the dark web. Ransomware is a service, and you don't even need to be technical to deploy it, but it's also adapting at a pace we've never seen. Just last week, I reported the same exact ransomware campaign against 3 different clients with 3 different file names and 3 different MD5 thumbs on each of the files. So that goes back to that example that it's very difficult to stay up to date with these attack vectors because they're constantly evolving and changing, and and resignaturing themselves. So with that, any questions that I can answer?
Yes, actually, Justin, thank you so much. Great information, and we do have a few questions from attendees. So we'll open it up for that. Just as a reminder, if you do have questions, go ahead and post them to the questions pane, and we'll fit several in right now. First question, what has caused the increase in the size of data breaches? Great question. Does Darktrace have any insight into that, Justin?
Sure. I don't think Darktrace does. I could tell you just my personal belief. I think it's a couple things. I think first and foremost, data is the keys to the kingdom in this day and age. Over the last 5 years, big data was the big buzzword. I think the problem is we collected so much data, and two things happened. We didn't truly know how to query that data and use it in the most efficient manner. And that's why you're also seeing this huge rush towards machine learning, because all these massive big data sets that we've been collecting over the years, now we're using machine. But the other thing is, I think if you just look at trends, I always like to tell clients the level of effectiveness of prior campaigns usually will dictate if we'll see more of it. And then you can kind of start to see it grow. 2 years ago, we saw the Sony, really the first instance of really allegedly state actor, affecting a private organization and trying to actually that organization by dumping the emails of those breaking their hardware. And then from there, we saw various other forms of that. We saw the Panama Papers. I mentioned earlier, most recently, David Beckham. And what the attackers are realizing is it's not even beneficial anymore to dump any credit card. So really an email that I would actually go as far as to say that your email servers are a sensitive piece of data.
Hey, Justin, you are breaking up just a little bit for me, so I assume you may be for the audience as well. I'm not certain if you could move around and see if you can find a couple more bars on your signal, or how to solve that.
Can you hear me now? How about now?
Yeah, that's a little bit better. So if you can maybe pick it up midway back, that'd be great.
All right, sure. Where did I leave off? Where did you guys lose me?
I think you were talking about email servers.
Sure. I would go as far as to say that email servers are probably the most valuable asset because we speak so freely, and it's probably the most sensitive information about where it comes. And I think attackers have realized that, and I think you're going to start to see more of that, dumping sensitive information like that and holding it for ransom. I think you're going to start to see more of is the IoT craze. I think the reason it got so centralized is because these devices we've grown so accustomed to and we rely so heavily on, we focus so much on in our computers and our PCs,
Yep, unfortunately, you're still breaking up a bit there, Justin.
Okay, sorry.
I'm not sure if you can, like I said, move around and see if you can find some more bars. Maybe while you do that, I'll just ask if Walt has any insight into kind of what's caused some of the increase or what you're seeing out in the market with the cStor clients. Any thoughts, Walt, on kind of what's behind all of this and the size of the data breaches increasing?
One of the thoughts that I think was interesting that I hadn't been aware of was the conversation around email as a valuable asset. And I guess as that gets outsourced more and more to Azure or to whoever customers are going to do that with, I guess, Justin, any comments about as it moves across the cloud into different venues from place to place? How does that impact things?
It's hard to say. Influx, migration. Just the cloud in and of itself is a bit of a gray area for a lot of companies. They don't have the visibility into that network. So, and for that specifically, I think time will tell when companies start to adopt that platform.
Great. I think we have a little bit better. You're still breaking up a tad, Justin, so but why don't we get on to a couple other questions and we'll try and squeeze them in. I know we're running slightly long, but there's some good ones here. The next question, how do you think threats will develop in the future? Where is this all headed? That's probably, referring to how do we get out ahead of this, and can we get ahead, or they always going to be one step ahead? Any thoughts there, Justin?
Yeah, I think you can get out ahead. I think where we're heading with it is we're going to start to see machine learning being used by the attackers. I think you're going to start to see artificial intelligence kind of flip. We've already started to see the very earliest stages of that. Malware that actually makes a decision based on its environment, changes itself, et cetera. And I think that's just going to continue to get more sophisticated. I think the best advice I could give to companies is start embracing a different approach to security. Didn't rely on what's worked for you the last couple of years, because attackers are very smart. They're some of the smartest people out there, and they know what is being used across multiple industries, and they typically tend to exploit that first. So start thinking out a little bit outside the box, I think, is the best advice I could give security teams.
Awesome, thank you. A couple other questions. Does Darktrace interface with other key cybersecurity tools such as Cylance or Splunk or others?
Sure, yeah. So we do have a full API. So anything you see on the screen, you can actually export out. We have a lot of clients that are heavily dependent on the SIEM architecture that they've invested a lot in. So we feel that, we're not going to keep our data in a black box. We want our customers to be able to use it across all the other platforms. And then as far as other companies like Cylance, and the other companies out there, we really complement them, because we're sitting so far on the inside of the network that it would only make sense that we complement those sitting on the perimeter of the network, So I very rarely ever tell a company to replace something in their security stack with Darktrace. We really tend to get along well with everything else, I've not come across a case where Darktrace has not augmented what's already out there for the team.
Great, thank you. That's good to know. We'll squeeze in one more question and then we'll wrap it up. Last question, how do email breaches impact smaller companies, smaller than Yahoo and LinkedIn, for example?
It's the same. I think size is not really dependent. I think it's just a matter of the content. Also, when you say, do we mean actually breaching the emails in and of themselves, or do we mean using email as an attack vector like ransomware? Regardless, I think small companies have many of the same problems that big companies do. Unfortunately, they don't have the resources to hire large security teams like the big companies do. And that's another, area of focus for Darktrace. One of our clients is a two-person hedge fund. And so by working more efficiently, letting the machine do all the heavy lifting for you, you can better focus your time and run a very lean security team. So I don't think there really is a black or white way to answer that. I think really they're affected in much in the same way. I would say a merger and acquisition for a small company is just as important and valuable as a merger and acquisition for a large company. So there are various different things that can affect them that are of equal value, I'd say.
Great. Yep, good to know smaller companies have options too, and the best tools aren't reserved for the largest. So that's always good news.
Yep.
We'll wrap it up on Q&A, but I thank you so much, Justin. Excellent information and obviously very timely. I'll just ask Walt if he has any closing thoughts